All right, I want to make a note about copying arrays in Java. And let me go back one here. When we use and pass arrays to methods, they do what's called passing a reference. So if I were to have some list, which was an array, and I were to assign it list to equal some other array. So here's what the memory looks like. There's the list for list 1 and the list for list 2. Once list 2 equals list 1, the contents of list 2 don't change, but list 2 points to list 1. There's no extra memory made and there's no copy. So any changes made to list 1 will show up in list 2. This isn't a memory efficiency thing that's done in a lot of programming languages. And there are really only three ways to copy arrays in Java. One is to make a loop that runs through each element and copies that element into the element of another array, or to use, which is what we have here. So using a loop, we have our source, and then we have the new, which is the same size as the source. And you walk through each element in the source array and put it into the new array. So it has to loop through, and you have to have this equal here. This will actually copy new memory locations and put the values in the new memory locations. Versus this method where array 1 equals array 2, this won't work. This loop will work. Or there is a method within system called array copy. So system.array copy, you put in the source array, you start at the first element 0, and you put in the target array, and you put in the second, the source and the target, and then you want the length. Now you could copy parts of arrays with array copy. Your target could be smaller and this length could be smaller, but array copy really creates the loops for copying arrays, and it's built into system. There's a third way called clone, which doesn't get introduced until Computer Science 2. Um, and then we've already begun passing arrays into methods. In the examples I've been using, I've been passing arrays into methods. And when we pass the array into the method, that method works on a shared array. The book also has a thing called anonymous arrays, where the print array statement here, this new integer and passing the array, because it has no name, this can pass an anonymous array. So in this example here, when we create this list here and print a list, the method itself gets a pass to this array. You could also call print array here, which they do in the second one, and give it an anonymous array that goes by it. There is a distinction by passing by value for a parameter of the primitive types, and those are the strings, the integers, the actual value is passed. I shouldn't say strings, the integers, the doubles, the cars, and changing the value of the local parameter inside of the method does not affect it outside of it. But for anything of an array type, the value of the parameter contains a reference, and any change inside the method changes the original. And we were exploiting that in our deck of cards to make our deck of cards work. And so what we want to do here is we want to find a way of returning an array from a method, and we want to find a way of sorting arrays. One of the things that's going to be really important is you'll find in the field of data science, when you get information in, it's usually good to have your information sorted in some type of order, because then when you go to look up your information, it makes it much easier to search through it. So what we're going to want to do is we're going to want to create a large array here. And what we're going to do is we're going to um, pass we're going to create a large array of random decimal double numbers, and then we're going to put it in order and sort it in order. And we're going to use this to practice searching through methods. So I'm going to come back over to Eclipse here. I'm going to bring my display window down. And what we're going to do is I'm going to make a new method in my chapter 7 stuff, or new class, and I'm just going to call this right now sort array. And so we have a new public class sort array. And I'm going to start immediately with methods. And what I'm going to do is I'm going to make a method that creates an array. So I'm going to pass an array back out of my public method. So I'm going to public static double array. And so I'm going to call this random doubles. And the only thing I'm going to pass to it is the size of the array I want to create. So I'm going to double. Let's see here. I'm going to pass a size, integer size. And so I'm creating a double that will create random doubles. And so what I'm going to do is for integer I equals 0 to size, I less than size, I plus plus, I'm going to create an array. So I guess here I will make a double. We'll call it the result. Your book likes doing that. New double of size. And what I'll do here is inside of my result, the ith element will be some random number between 0 and 1. So let's result I equals math.random. And right now it'll be decimal. And then we'll return the array. So what I've made is a method that generates a random array. So let's come over here and let's use this. Let's make a double random array. Whoops. We'll call it our rand array. I'll call it randar, and we'll have it get random doubles. And for right now, I'll give it 100 random values. So what I've done is I've made a method that returns an array, and I'm holding it in memory for random array. So let's look at random array here. So I'm going to make a for loop for array. Well, maybe let's print out an array. So we'll make print array a function, and we'll send it our random array. So I'm going to make another method. Now notice again, since we have methods now, my way of thinking when I'm writing a program, again, I would put a lot more comments in an official program, but I want to print the array. Instead of writing the code to print the array in my main, I make a method to do it. So every time I want to print the array, I'll call the one method. So we'll do static void print array, and it will be getting a double. Oops. And this will be the array it's printing. And to print an array, we'll go for integer I equals 0. I less than the size of the array. So this becomes a little algorithm we keep using, is we do our for loop to be less than the size of the array. And we'll do system.out.printf percent f, because it's a floating point, and array I. And that should be enough to print this out. Let's see if this works right now. I'm printing 100 things, so this is going to scroll up, but I'm going to show you what the problem is that we're trying to fix or deal with here. So let's see. Oh, I didn't put any new lines in it, so let me come out of here and put a new line in so we can get a big list of everything here. I'll run it again. Oh, yep. Let's put our new line here. Printf, new line. I just want to see the problem we're dealing with. Uh-oh, what did I do wrong here? Let's see, print array, that's good. So, oh, print line. There we go. So I have a whole bunch of random decimals that aren't in order. Now, if I needed to search here for a particular value or something close to a particular value, it would be a very hard search. I would have to look at each thing. And so one of the things we tend to do when processing data is near the input side of the data, we sort our data in some type of order, alphabetically, higher to lower, zip codes. We usually have some sorting mechanism so that when we have to find something in here, we don't have to look at each piece. Just like when you're going to work on a puzzle, you put all the edge pieces off to the side and all the middle pieces, and sometimes you'll sort, where you see sky background or certain colors, so that when you go to build the picture, you're not looking at each piece to find things. You find your edge pieces and you find certain colors, and then you match from within there. And that's what we're going to do with an array. So we have this array of random values between 0 and 1. So what we're going to want to do is we're going to want to sort the array. So we're going to sort our random array. And then we'll print it again. So in fact, I will comment out the first print because you saw how random it was, and we'll go to the second print. So the thing we want to do here is we want to make a sort mechanism. We want some way of getting the arrays into order. And so what we're going to do is we're going to work our way from the beginning of the array to the bottom, and we'll move the smallest number to the top. So we'll have it in descending order. So public static void, we're not going to return an array. We're going to just sort the array that comes in. And we're going to use a process called a selection sort. I think is, let's see, or do I want to use a bubble to start with? and we'll send it the double array here. All right. So when we sort an array, we're going to try to find the smallest number. So when we look at the first element in the array, right now it's the smallest number we see. And I think, let me, if I can switch over to the slides here, there's a good slide that shows this. Let me jump down. There's the search. Want to sort. Yeah. So over here, when we first look at this array, 2 is the smallest number. And so what you want to do is you start with 2, it's your smallest number, and you look at your next number. 9, is it smaller than 2? No. 5, is it smaller than 2? No. 4, is it smaller than 2? No. 8, is it smaller than 2? No. 1, is it smaller than 2? Yes. Then it plops 1 into the first spot and 2 into the spot where 1 was. It swaps them. Then it works its way to the next number, which is 9 in the list. And it swaps those. Then it swaps 4 and 5, and so on. And so it keeps, notice how it starts with the 0th element and gets that to be the smallest number. Then it starts with the first element and gets that to be the smallest number. And it keeps working its way through the elements until it gets to the second to last number. And all the swaps will have guaranteed it fell into order. So what we need to do is we need to make a selection sort that works its way through the list and swaps everything out. So that's what we're going to try to do, is we're going to focus on the first element, and then we're going to work our way down to the last element. Notice that this kind of looking and swapping is going to take 2 loops. One to count, are we on the first or the second, and then in one to search underneath all of those. So let's build that into here. So what we're going to do is we're going to sort everything out and work our way through. So the first thing we need to do is for our integer I, this will be our first list, we'll make it equal 1, or 0, I'm sorry, the 0th element, and I will be less than array.length. Again, this is really common, I++, and so this is going to walk us through everything. Now, we're going to need some double that is the current minimum value. And right now, it's the thing in the ith position. Because our first number, the first time we look at it, that is the current minimum value. But we also need to know where it's at. So we need to index it. And that's going to be I. And then what we're going to do is we're going to work our way through the entire list and find the next smallest thing. So we're still inside our for loop here. And we're going to work our way around, and we're going to work our way from a j that is equal to I plus 1. We're going to start with the next thing we're at, and we're going to go until j is less than the length of our array, and we're going to increase through j. And if the current minimum is bigger than our jth element, then we found something smaller. Now what we have to do is we have to change our current minimum, because our current minimum is going to be the jth element, and we have to update our index to be the jth element. So we assume the first thing in our list is the smallest thing, and we search through the rest of the list to see if it really is the smallest. If the current minimum does not equal I, so if our I is not the smallest thing, then we're going to swap these. And so we do a swap. We take the current minimum, which is not I, and we have it equal what's in I. Because I wasn't the smallest, so we push I down where, whoops, this should be array. This is array. I was calling it list for a second. Why am I calling it list? This is array. Array and list are similar terms in programming. I lost my mind for a second. And then in the array ith element is going to swap with the current minimum. And that's all we need to do. We need to assume the thing that's starting in our loop is the smallest thing. We search for the rest of the list and we swap. And we keep repeating this, making the list smaller, because as soon as we find the smallest thing, we move it to the top. And then we move one further down. And so these two little if loops here should do the work for us. So let's see if we can get our 100 numbers in order here. Oh, I made a small typo. What did I do? The method is undefined. So sort array. Oh, I called it selection sort, didn't I? I changed my name as I was going to match the book. I called it sort array up here. And in my method, I called it selection sort. That's an easy fix. We'll just call it selection sort. And lo and behold, we know because we printed it out before that this was random. Right? When we first started, we printed it out. But notice how it put them all in order. And sorting is a very, very, very important part of working your way through data. And there will be different algorithms that you get to sort data depending on how you're getting the data and what you need to do with the data. A selection sort is a pretty healthy algorithm. Another method is called a bubble sort. Which makes several passes through the array. What it does is it always looks at neighbors. And so it swaps the neighbors, kind of bubbling up the smallest values. Sometimes bubble sorts or a sinking sort, because the smaller bubbles, the smaller values bubble their way up to the top. So there's this method searches through the whole thing, finds the smallest value and moves it to the beginning. Then it goes to the second value, looks for the next smallest value, puts it into the second value, and works its way down the list, always making sure that it pulls the smallest thing up to the very top. And so we've now sorted our data. And so sorting makes it easy for us to start searching our data. And we'll look at search algorithms in the next video.